Hi class, we will solve the problem number 12.4.5. It is little bit different than the earlier two problems. So I will read out the problem. Design a short helically reinforced column of unsupported length 3.75 meter to carry axial load of 1200 kN. Period. Use concrete M20 and steel grade of Fe250. Period. Assume effective length to be equal to unsupported length. Period. So given R FCK as usual 20, then Fy 250, then L or unsupported length, both are same. Effective length, unsupported length are equal, that is 3.75 meter, and P ultimate load to be carried, load carrying capacity, not the ultimate load. So axial load is 1200 kilonewton. So we have to design this as a circular column. Okay, so let's design this as a circular column. So our job is to find out the dimensions of the column. We know that column to be a small column, LE by D should be less than 12, or D is equal to 3750, that is 3.75 meter. This is in mm divided by 12. So D is equal to 3.13 mm. This is one condition. Another condition to apply the equation 12.5 is that to apply the equation 12.5, it is given in the book. So if you refer all the equations we studied for this problem, ABC 12.5, another condition is that D should be greater than 400 mm or 0.12 L. So this is 400. Now find out the 0.12 L. So 0.12 into L is 3750, and so this will come to 450. So in this case it is required, or whichever is the getter, in this case whichever is the getter. So we have to consider D equal to 450 mm. So diameter of the circular column will be equal to 450 mm, provided this is to be designed as a short column and this is to be designed as axially loaded column, short as well as axial loaded column. Then find out the other requirements so that we can proceed with the design. So AG, find out the gross area. We know that pi by 4 into 450 bracket square. So gross area will become 159,043 millimeter square. Then find out the ultimate load carrying capacity, because load carrying capacity is given. So PU will be equal to 1.5 into 1200. So this will be equal 1800 kilonewton. Then assume that we are using the helical reinforcement, or we are that to be designed, we are using the helical reinforcement and 5% increase in strength is permitted. Strength increase is allowed, means the equation given at I will tell you the number. Equation given at 12.7b. So 12.7b is satisfied. So equation 12.7b is satisfied. Okay, so if this is so, we can write the formula for PU. So PU will be equal to 1.05. We know that. Then into bracket 0.4 FCK is 0.4 FCK into AG plus 0.67Y 7fy minus 0.4 fck, and for this bracket it is ASC multiplied by ASC. So this is the formula for PU. I will write one more time. PU equal to 1.05 big bracket 0.4 FCK into AC plus another bracket, small bracket 0.67 FY minus 0.4 FCK, small bracket complete, multiplied by ASC, and big bracket complete. So plug in the values. If we plug in the values, it will be like this: AU 1800 into 10 raised to 3. This is in Newton, right? 1.05 into 0.4 FCK is 20 into AG is 159043. This is first bracket plus into second bracket I will write here 0.67 into Fy is 250 minus 0.4 FCK into 20, FCK is 20. This small bracket complete, and it is multiplied by ASC. We have to find out the ASC, and this big bracket is also complete. So from this, ASC will be equal to area of main steel or main steel or longitudinal reinforcement 2771 millimeter square. Once we know that, now we have to provide the bar such that so in case of the circular column, generally 6 number of bars are provided, 6 number, and diameter is each having diameter 25 mm. So total area we will be providing in this case is 2945 millimeter square. So we are providing little bit extra over this area, so that is fine. Then provide the helical reinforcement or the diameter of the helical reinforcement. So we are now designing helical reinforcement. So it should be 5 helical reinforcement, diameter should be greater than 25.4. So it is equal to 6.25 mm. So to satisfy that, we have either 6 or 8. So provide 8 mm. So helical reinforcement diameter will be 8 mm. And then area ASC, area of this reinforcement if you calculate by pi by 4 d square, that is 8 square, it will come to 50 millimeter square. Then we have to find out the DK. Diameter of the core will be equal to 450 minus 2 into clear cover, that is we assume here 40. Clear cover is 40. So DK, diameter of the core, will be equal to 370 mm. So we are calculating all these to satisfy the equation 12.7b. So one more parameter is required, AK. So will be pi by 4 into 370 square, that is diameter of the core, and this is minus area of steel, longitudinal steel. So this will come to 104,576 millimeter square. Now we have all the things, and we will consider now equation 12.7b, and we will calculate the first part of it. We will calculate the right hand side part of this RHS, and we will equate that to the left hand side part, and from this we will get another quantity, that is small s, that is spacing of the lateral ties. So we are doing this for finding small s. So let's do this. RHS is equal to right hand side part is 0.36 into bracket 0.36 FCK into bracket AG by AK minus 1 divided by Fy. So let's calculate this part. So I will plug in the values in the next slide. So this is equal to 0.36, FCK is 20 into AG is 159,043 and AK is 104,576 and minus 1 divided by Fy is given as 250. So this right hand side part, RHS part of that equation, comes to 0.015. Now equate this to the left hand side part. So left hand side part is pi dk into ASH divided by AK into small s. So we know everything except this small s, this quantity. So let's do it. I will write one more way, pi dk into ASH divided by AK into small s equal to 0.015. That is right hand side quantity we already calculated. So from this find out the pi dk is 370, area is equal to 50, area of the core is 104,576 into small s equal to 0.015. From this we get small s equal to 37 mm. We can keep this as it is, or maybe you can round up to next value in multiple of 10, that is 40 mm. So spacing of the lateral ties, that is helical ties, will be equal to 40 mm. So provide s equal to 40 mm. Check for, now just provide the check for pacing, or checks for the pacing. So this pacing, first requirement is that s should be less than 75 mm or 370 by 6, that is core diameter 370 by 6, whichever is the small or less. So if you calculate this and this, so our provided s, this s is already small than this condition is satisfied, which is okay. Another condition is that s should be greater than 25 mm or 3 times its diameter of the helical, which is equal to 24. So 3 times diameter of the helical reinforcement, which is equal to 24. So it should be greater than 24, and this is 25 and 24. So this condition is also satisfied because we are already providing s equal to 40 mm. So this is all about the design of this problem. We have the gross area, we have the longitudinal reinforcement, we have the pacing of the longitudinal reinforcement. Pacing of the longitudinal reinforcement will be like this, just 6. This is 6 bars at equal distance, because this is circular. We have the diameter of the helical reinforcement 8 mm, and we have the pacing of the helical reinforcement, that is 40 mm. Thank you.